Hiya! In today's episode of Bridging to a 7, we'll focus on integration. You have one fancy integral in front of you, as well as the bounds, and you're asked to find the exact value of k, which is hanging on the integral. So, usually when you're presented with choices, always take the hint. 11 times out of 10 is going to be faster than you coming up with your own approach. So, if u is equal to e to the x, the u is equal to e to the x dx. When making the substitution, we'll also change the bounds. The own bounds for x were ln 5 and k. Therefore, the bounds for u is going to be e to the ln 5 and e to the k. E to the ln 5 is equal to 5. So the new bounds are going to be 5 and e to the k. We need to have e to the x dx in our integral. So what I'm going to do first is multiplying e to the x to both the numerator and the denominator. This part, e to the x dx, will become du. The new bounds are 5 and e to the k. What we're left with is u squared minus 3u minus 4. Look at this integral. There's only one feasible way going forward, and that is using partial fractions. And the reason I can suggest this straight away is that we noticed that this quadratic can be factorized. So let's pull this guy aside and do some partial fraction decomposition. If you're watching this video, most likely you're quite fluent with the basics. We are now going to plug in some values of u that will make our life easier, notably -1 and 4. Why did I choose these values? Because if you plug in -1, the first term will be 0. If you plug in 4, the second term will be 0. So we have 10 equals to 0 minus 5b, and 10 equal to 5a plus 0 respectively. And from here, you can easily deduce the values of a and b. We will now use our partial fraction decomposition to integrate. Integrating the first fraction, you will get 2 ln of u minus 4. Integrating the second fraction, you will get 2 ln of u plus 1. We can now plug in the upper bound and the lower bound. Notice also from earlier that u has to be greater than 5. So we can actually remove the absolute value signs. So we should do that before plugging in the bounds. Plug in the upper bound. Plug in the lower bound. Let's now combine the logarithms. When adding two logarithms of the same base, you multiply the arguments. When subtracting two logarithms of the same base, you divide the arguments. So in this case, we will have e to the k minus 4 divided by e to the k plus 1 divided by 1 times 6 in our argument. Voila. Let's go back to the question. We're given that the value of the integral is equal to ln of 25. So all that's left for us to do is setting this value equal to ln of 25 and then solve for the value of k. "25 is 5 squared. So ln of 25 is ln of 5 squared, or 2 ln of 5. We can then simplify the 2's, and we notice that the arguments have to be equal for the 2 to be equal. Now we just have to solve a very straightforward equation. And we found out that k is equal to ln of 29. So this is the end of a challenge question. It may seem intimidating at first, but just keep pushing and you will realize that the hard question is nothing more of a series of easier questions bundled together.